Good afternoon. Today we will solve problem using GOMORY'S cutting plane algorithm. This is the problem from Singeriasu S. Rao, Engineering Optimization Theory and Practices, 3rd edition. So we will be solving one problem, GOMORY cutting plane algorithm from this textbook. So let us consider the problem minimize so our objective function is minimization. F is equal to minus 3 into x1 minus 4 into x2 subjected to the constraint 3x1 minus x2 is less than or equal to 12. 3x1 plus 11x2 is less than or equal to 66. Xi is greater than or equal to 0 and integers. I value ranges from 1 to 2. This is our problem. So here the objective function, you can see it is a minimization and these are the two constraints. What is our first step? We have to convert this into the canonical form. So convert this into the canonical or the standard form. So here 3x1 minus x2 plus s1 is equal to 12. Then 3x1 plus 11x2 plus s2 equal to 66. Then, so we have to now include this in our objective functions. So objective function is minimize f is equal to minus 3x1 minus 4x2 plus 0 into s1 plus 0 into s2. Next, we'll solve using the simplex method. So you know the simplex method, BB, CB, XB, and here the decision variables x1, s2, slack variables s1, s2, and your minimum ratio. Now, BB, CB, XB, and here you have to write the CJ value, coefficients x1, x2, s1, s2, minimum ratio. So now first we'll fill this. What is the coefficient of x1 in your objective function? Minus 3. Then x2 minus 4. Then 0. Okay. Now, what is your basic variables here? We'll be considering this s1 and s2 as a basic variable. s1, then s2. So these are the basic variables initially. And what is this? The coefficient in the objective function? The coefficient of objective function in s1 is 0, s2 is 0. And what is the RHS of the first equation where you have included s1? It is 12. And here it is 66. Fill the table. So you know now already. So the coefficient of x1 is 3, then minus 1, 1, 0. So 3, 11, 0, 1. Next. What is your next task? You have to find out Zj value. What is Zj value? CB into Xj. J equal to 1, 2, S1, S2. So, summation of. So, 0 into 3 plus 0 into 3, you will get 0. 0 into minus 1 plus 0 into 11, you will get 0. Since it is a 0 here, for the first iteration, you will get all here Zj value equal to 0. What is your next task? You have to find out Cj minus Zj. What is Cj minus Zj? So here Cj value is minus 3, minus 3, minus 0. So you will get minus 3. Minus 4, minus 0. You will get minus 4. 0 minus 0 is 0. 0 minus 0 is 0. Now, what is the next task? After finding this, you have to check the optimality condition. What is our optimality condition? Optimality condition says that you stop the iteration when Cj minus Zj is greater than or equal to 0. Is our Cj minus Zj is greater than or equal to 0? No, it is negative. It indicates you have to further continue to the next iterations. How will you continue to the next iterations? You have to find out entering variable and the leaving variable. To find out entering variable, what is the formula? The most negative Cj minus Zj will be the value in the the value for the leaving variable. Which is most negative here? This is most negative. So the value corresponds to this. X2 is called as leaving variable. Okay. Now the entering variable. Which is the leaving variable? How will you find out? So the formula is xb divided by value in the entering variable. So 12 divided by minus 1. Since it is minus, we won't be considering this. We will be writing this as a hyphen. Then 66 divided by 11. 66 divided by 11 is, you will get 11. Which is minimum among this. Since we have only 1, this will be considered as a leaving variable. The value correspond to this is called as leaving variable. This is entering variable. This is leaving variable. Where exactly entering and the leaving variable coincides, this is called as pivot. Iteration number 2. Now, you have to again complete this table. B, B, C, B, X, B, S1, S2, S1, S2. What is the changes? X2 will enter in the place of S2. So, instead of S2 here, you have to write X2. Now, what is the coefficient of S1 in the objective function? 0. What is the coefficient of X2 in the objective function? Minus 4. Now, how will you fill this table? So, this is our new row. The formula is old value divided by pivot. So, 66 divided by pivot is 11. So, you will get here 6. 3 divided by 11. So, 3 divided by 11. 11 divided by 11 itself. 1. 0 divided by 11. So, 0. 1 divided by 11. You will get 1 by 11. How will you fill this table? Again, use the formula old value minus new value into value in the entering column. So, since you all are very familiarized with how to calculate these values, I am directly writing these answers, and if you want, I will be providing these notes. So, all these details are here. Now, 18, 36 by 11, 0, 1, 1 by 11. Next, how will you find out Zj value? Cb into x1 plus minus 4 into 3 by 11. So, you will get minus 12 by 11. 0 into 0 plus minus 4 into 1. You will get minus 4. 0 into 1 plus minus 4 into 0. It is 0. 0 into 1 by 11 plus minus 4 into 1 by 11. 4 by minus 4 by 11. Cj minus, this is your Cj value, minus Zj value. Minus 3 minus of minus 12 by 11. So you will get here 21 by 11. And then minus 4 minus of minus 4. So you will get 0 here. 0 minus 0 is 0. 0 minus of minus 4 by 11. So you will get 4 by 11. What is our next task? Again, whether we have reached our optimality condition. What is the optimality condition says? Cj minus Zj should be greater than or equal to 0. Is our Cj minus Zj is greater than or equal to 0? No, we have a negative number here. If we have a negative number, it indicates we have to further proceed to the next iterations. And the most negative among this will be considering as a entering variable. Since we have only one negative number here, this will be considered as a entering variable. So this is our entering variable. How will you find out the leaving variable? Again use the formula. Xb divided by value in the entering variable. Xb divided by value in the entering variable. So if you do this one, you will get here 5.5 and 22, which is minimum. The name itself says minimum. So which is minimum among this? This is minimum among the two. This will be considered as leaving variable. Where exactly the entering variable, leaving variable coincides. This is called as pivot value. So next again we have to further move to the iteration number 3. Now how will you find out the values for the new row? Old value divided by pivot. The remaining value is old value minus new value into value in the entering column. Next we'll further proceed to the next iterations. So this is iteration number 3. Okay. What we have to do? Again, instead of S1 is leaving now, which is entering X1. So I had written X1 here. This is X2 here. So what is the coefficient of X1? Coefficient of X1 is minus 3 and coefficient of X2 is minus 4. So how will you find out the values here? Old value divided by pivot. Then here old value minus new value into value in the entering column. So do the calculations here. For your reference, you can refer all these calculations. So next you will get here 11 by 2, 1, 0, 11 by 36, 1 by 36. And here 9 by 2, 0, 1 minus 1 by 12, 1 by 12. So you will get the values like this. So find out the Zj value. What is the Zj? Zj equal to Cb into x1 plus minus 4 into 0. So minus 3 into 1 plus minus 4 into 0. You will get here minus 3. You will get here minus 4. Minus 7 by 12. Minus 5 by 12. What is your next task? You have to find out Cj minus Zj. So find out Cj minus Zj. So you'll get 0 here and 7 by 12, 5 by 12. Okay. Now what is your task? Once if you find out Cj minus Zj, check the optimality condition. What is optimality condition says? Cj minus Zj should be greater than or equal to 0. Is our Cj minus Hj is greater than or equal to 0? Yes. All are a positive here. It indicates we have to stop the iteration here. If you stop the iterations, what you have to do? Write down the values for x1 and x2. So what is the value of x1? The value of x1 is the corresponding value in that particular row for the xb value, 11 by 12. 2. Then x2 is equal to 9 by 2. Okay, and what is the z value? Z value equal to minus 3 into 11 by 2 plus minus 4 into 9 by 2. So if you find out this, you will get minus 69 by 2. Now, is this the values are the optimal solutions? No. What we have given in the question, x1 and x2 should be integers. So that is the reason we are using GOMORY'S cutting plane algorithm to cut the fractional part of this and to get the integer as a answer to these values for x1 and the x2s. Now we have to select to generate the GOMORY'S constraint whether we have to choose x1 or whether we have to choose x2. So to select whether to select x1 or x2, we have to use the formula. So what is the formula? The formula says that the fractional part of x1 and the fractional part of x2, whichever is greater, you consider that as a value for generating the GOMORY'S cut algorithm constraints. So let us consider x1 is equal to 11 by 2, x2 is equal to 9 by 2. It is a mixed fraction. So represent this as integer plus fraction. You will get 5, 1 by 2. This is integer of x1, fraction of x1. This equal to 4 plus 1 by 2. Integer of x2, fraction of x2. What is the formula? Formula says that whichever is maximum among the f of x1 comma f of x2, that is maximum among the half comma maximum among 1 by 2 comma 1 by 2. Since there is a tie here, we cannot, since both the fractional part of x1, fractional part of x2 is the same, so there is a tie here. In this case, what we have to go do, we have to again find out the fractional or the, it's like differentiation, second order differentiation. So how will you find out? For x1, it is f of x1 divided by fractional part of s1 plus s2. For x2, f of x2 divided by fractional part of s1 plus s2, the corresponding row for x2, here the corresponding row for the x1. What is the fractional part for f of x1? Half divided by, what is for the x1 row, what is the corresponding fractional part of s1 and s2? What is s1? s1 for x1 is equal to 11 by 36, s2 is equal to 1 by 36. So here how we can represent? We cannot, it's not a mixed fraction. Then you consider x2. For x2, what is the s1 value? Minus 1 by, for s1 minus 1 by 12. For s2, 1 by 12. Whether you can represent this as an integer plus fraction? Yes, you can write this as minus 1 plus 11 by 12. correct? Minus 1 plus 11 by 12. Now you consider this. How will you represent this? This can be represented as 0 plus 11 by 36. This can be represented as 0 plus 1 by 36. This is the integer part, this is the fraction part. So, fractional part of for x1, s1, 11 by 36 plus fractional part of s2, 1 by 36. So, you will get here 1 by 2 into 36 by 12. 3, so 3 by 2. You will get 1.5. Now, find out the fractional part for x2. x2, the fractional part of x2. What is the fractional part of x2? Half divided by fractional part for s1 and s2. What is s1? Fractional part 11 divided by 12 plus 1 divided by 12. Okay, so you will get 1 divided by 12, 2 into 12 divided by 12. This get cancels. So you will get 0.5. So which is maximum among 1.5 and among 0.5. So maximum is 1.5. So select x1 to generate the GOMORY constraints. This is how you have to select which variable among x1 and x2 will be considered to generate the GOMORY constraint. So here we have got x1 to generate the GOMORY constraints. So we'll see how to generate. So this is your x1 row in the last table. So how will you write? 1 into x1 plus 0 into x2 plus 11 by 36 into s1 plus 1 by 36 into s2 equal to, what is this RHS or the solution, or what we call as XP? XP value for x1 is 11 by 2. Now, again you have to represent this in integer plus fraction, integer plus fractions. 1 into x1, so I will represent this as 1 plus fraction is 0 into x1 plus this is anyhow 0. This is 0 plus 11 by 36 into s1 plus this also 0 plus 1 by 36 into s2 and this is 5 plus 1 by 2. Okay. Now consider only the fraction part of this. This becomes 0 into x1. Fraction part is 0 into x1. So I will not consider because 0 into x1 is 0. 11 by 36 into s1 plus 1 by 36 into s2 equal to fraction part is half. And usually this will be greater than or equal. So how will you convert? You will multiply this with the minus 1. So minus 11 by 36 into s1 minus 1 by 36 into s2 less than or equal to minus 1 by 2. How will you make this one equal? So the final equation will be minus 36 into s1 plus minus 36 into s2 plus add a GOMORY constraint here g1 equal to minus 1 by 2. This is our GOMORY constraint equation. So now what we have to do? Include this in the last table. Okay. Now you have to include here the GOMORY constraint also g1. Now this one I will write it as g1, and since this g1 is not there in the objective function, coefficient becomes 0. Now, here you have to include now G1 and here this becomes Cj minus Zj. So 0, 0, 7 by 12, 5 by 12. And this becomes minus 3, minus 4, minus 7 by 12, minus 5 by 12. This row is reserved for now our GOMORY constraints, and Cj and Zj values, Zj and Cj value will not change because the inclusion of this will not affect our Zj as well as the Cj minus Zj values. So include G1 here. What is the RHS of G1? G1 is equal to minus 1 by 2. Then minus 1 by 2. What is the coefficient in the objective function? 0. Then x1. Whether x1 is there here? No. Whether x2 is there here? No. Whether s1 is there? Yes. What is the coefficient? Minus 11 by 36. Here minus 1 by 36. Now here all Cj minus Zj is greater than or equal to 0, and whether all our xb values are positive? No. Since xb value is less than or equal to 0, because we have got here our optimality condition says this should be greater than or equal to 0. But in our case it is less. So we have to use the dual simplex method. So in case of the dual simplex method, the most negative number of exb will be considered as the leaving variable. This will be our leaving variable. Now you have to find out the entering variable. How will you find out the entering variable? To find out the entering variable, you have to use the formula. Theta is equal to the minimum of Cj minus Zj divided by value in the leaving variable. Value in the leaving variable row. Now, what is the Cj minus Zj value here? I will write the theta values here. What is this Cj minus Zj? 0. So this will be representing as hyphen and hyphen. What is Cj minus Zj for S1? For S1 it is 7 divided by 12. 7 divided by 12 divided by value in the leaving variable. For S1, what is the value in the leaving variable? 11 divided by 36. 11 divided by 36. You should not consider the sign here. So 7 divided by 12 into 36 by 11. So you will get here 321 by 11. Next, similarly you find out for S2. S2 is equal to theta equal to, what is the Cj minus Zj? 5 by 12. 5 by 12 divided by the value in the leaving variable. So 1 by 36. So 5 by 12 into 36 by 1. So here again this is 3 is a 15. Okay. So you will get here 21 by 11 and 15. So theta is equal to minimum of, what is minimum of 21 by 11, which is corresponds to S1. For S2 it is 15. Which is minimum among this? Minimum among this is S1. So we will be considering this S1 as a leaving variable. And where exactly the entering variable? Where exactly this leaving variable, entering variable coincides, This is called as pivot value. Next iteration is, this is our entering variable, this is our leaving variable. So S1 will enter in the place of G1. That is why S1. What are all the coefficients? X1 coefficient is -3, X2 coefficient is -4, S1 coefficient is 0. Find out the values. How will you find out the values? Again the formula. Old value divided by pivot. For these two, old value minus new value into value in the entering column. So find out the values. You will get the values as 5, 1, 0, 0, 0, 1. 51 by 11, 0, 1, 0, 1 by 11, minus 3 by 11. So here 8 by 11, 0, 0, 1, 1 by 11, minus 36 by 11. So once these tables are filled, what is your next task? Find out Zj value. Zj value is equal to -3 into 1 plus 4 into 0 plus 0 into 0. So you will get here -3. Similarly, you have 1 here -4. Similarly, you have 1 here. 1 into 0 becomes 0. You have 0 here. So here you have -4 by 11. Here you have -3. Minus of minus. So plus 4 into 3 by 11 plus 0. So you will get here -1. Now you find out Cj minus Zj. -3 minus of -3. So it becomes 0, 0, 0, 4 by 11 and you will get 1 here. Now check once this is done. What is our next step? Find out or check the optimality condition. What is the optimality condition? Says that Cj minus Zj should be greater than or equal to 0. Is or Cj minus Zj is greater than or equal to 0? Yes, it is greater. So greater, and all the xb values are positive. So it indicates stop the iterations. So write down the values of x1 and x2 and this s1. x1 is equal to 5. x2 is equal to 51 by 11. S1 is equal to 8 by 11. Z is equal to -3 into 5 plus minus of 4 into 51 by 11. So minus of 4 into 51 by 11. So you will get here -369 by 11. Now whether we can stop here? No, we cannot stop because x1 is integer but x2, s1 are not integers. Again, to cut the integer part, fractional part of this one, what we have to use? We have to again use the Gomorrys cut plane algorithm. So we'll see. Now since we have here x2 and s1, whether to select x2 row to generate the Gomorrys constraint or whether to select s1 row to generate the Gomorrys constraint, we have to use the formula. What is the formula? Formula says, so here the maximum fractional part represent this. x2 is not integer, so we have got 51 by 11. s1 we got 8 by 11. Now represent this. So if you represent this, this becomes 4. The remaining is 7 here. This 11. So you have here 8. This is 18 by 11. So this will be 18 by 11. So this is 18 by 11. So 18 by 11. So 11 ones are. So 7 by 11. What is the fractional part? How will you choose? The maximum fractional part of x2 divided in from among f of x1, x2, s1. Which is the highest maximum fractional part? You have here 7 by 11. Fractional part is again 11. Now, so both are equal here. So x2 fractional part is also same, x1 fractional part is also same. In this case, either you have to apply the formula once again, or else arbitrarily select either x2 or s1 to consider for generating the GOMORY constraints. So let us directly consider, instead of solving again, I will consider x2 as a variable, x2 row I will be considering to generate the GOMORY constraints. So now how we have to proceed here? So this now we have selected x2 row. Now how will you write? 0 into x1 plus 1 into x2 plus 0 into s1 plus 1 by 11 into s2 minus 3 by 11 into g1 equal to, what is this xb value? 51 by 11. Okay, this is anyhow 0, this is 0, and how will you represent this? 1 as integer plus fraction. Integer is a 1, fraction is 0, plus here how will you represent 1 by 11? So this is integer is 0, fraction is 1 by 11, yes 2. Now here integer is 0, fraction is minus 3 by 11 into GOMORY 1 equal to, how will you represent this as integer plus fraction? 4 plus, here you will get 7 by 11. Correct? Now consider only the fractional part. Fractional part is 0 here, so this is out. Fractional part is 1 by 11. So 1 by 11 into s2 minus 3 by 11 into g1 equal to 7 by 11. Okay. So here usually the equation or the condition will be greater than or equal. So we will be converting this and again into less than or equal. Minus 1 by 11 into s2 plus 3 by 11 into g1 is less than or equal to minus 7 by 11. Now how will you make this one equal? Minus 1 by 11 into s2 plus 3 by 11 into g1 plus g2 equal to minus 7 by 11. So this is our GOMORY constraints. Now what we have to do? Include this expression in the last table. So in the last table, this is your last table, you have to include here. So as I said, the inclusion of this will not change our Zj and Cj value. So I will just copy the same. So this is Zcj minus Zj. I will just copy this one down. 0, 0, 4 by 11, 1. And in this space I will just write minus 3, minus 4, 0, minus 4 by 11, minus 1. In this place I will reserve for now our GOMORY constraint G2. And here I will include one more column G2 and its coefficient is 0. So how will I write now? G2 coefficient is 0 and what is the solution value? Minus 7 by 11. Minus 7 by 11. And whether x1 is there in this equation? No. So 0. x2 is there in this equation? No. 0. Whether s1 is there? Yes. minus 1 by 11. Whether S2 is, no, S2 is there. So S1 is 0, S2 is minus, S2 is minus 1 by 11, and G1 is 3 by 11, G2 is 1. So since it is 1, rest all will be zeros, and here also absolutely you will get zeros. What is our next task? So again you find out whether we have reached our optimality condition. What is the optimality condition says? Cj minus Zj should be greater than or equal to 0. Yes, all our Cj minus Zj is greater than or equal to 0, and then you check whether xb values are positive. Whether xb values are positive here? No, we have a minus symbol here. This indicates we have to further continue the iteration, and this will be considering as a leaving variable. So how will you find out the entering variable? Again you use the formula. What is the formula? Formula says that theta is equal to, here theta value equal to minimum among Cj minus Zj. You should not consider the sign here, divided by value in the leaving variable. Okay. So 0 divided by something, 0 divided by something is 0, 0 divided by something is 0, so here it is 1. And here 4 by 11 divided by value in the leaving variable, 1 by 11. So 4 by 11 into 11 by 1, you will get 4 here. And how will you write this one? This becomes 1 divided by value in this will be 3 by 11. So you will get 11 by 3. So 11 by 3. So some value you will get here. Maybe I have missed somewhere. So here you will get 4 by 11, this is correct, and here you will get, just cross check again, you will get here 21 by 11. So here you will get 4 and here you will get 7. Just check again, you will get here 21 by 11, and this one here you will get 21 by 11, and here you will get actually 7. So which is the minimum among this? Minimum among this is this. So this will be considered as a entering variable. And where exactly this entering and the leaving variable coincides, minus 1 by 11, this is called as pivot value. So we'll see the next table. So here we got this is entering variable, this is leaving variable. So this will enter here in this place. So the variable becomes x1, x2, s1 and s2. So write this corresponding coefficient in the objective function. X1 coefficient is minus 3, x2 coefficient is minus 4, s1 is 0, s2 is 0. So fill the table. You all know the equation now. For this, the old value divided by pivot and the remaining the rows, old value minus new value into value in the entry column. So find out the values here. You will get 5, 1, 0, 0, 0, 1, 0. 4, 0, 1, 0, 0, minus 8 by 33, 1. 1, 0, 0, 1, 0, minus 107 by 33, 1. 7, 0, 0, 0, 1, minus 1 by 3, minus 11. Next, find out Zj value. zj value you will get minus 3, minus 4, 0, 0, minus 67 by 33, minus 4. Find out a Cj minus Zj value. You will get 0, 0, 0, 0, 67 by 33, 4. Now, check the optimality condition. What is optimality condition? Cj minus Zj should be greater than or equal to 0 and xp should be positive. All should be greater than or equal to 0. So here all the values are positive, and here also if you see xp, all the values are positive. Stop the iterations and note down the values of x1, x2. So x1 value here is, you will get 5, x2 value here is 4, s1 value is 1, s2 is 7. Correct? All are positive here. And what is z? Z is equal to minus 3 into 5. Minus 3 into 5 plus minus 4 into 4. Minus 4 into 4. So you will get here minus 31. Since it is a minimization problem, we will get here minus 31. And x1, x2, s1, s2 all are positive here. So we have to stop the iteration here. x1 is 5, x2 is 4, and the objective function z is equal to minus 31. All are positive, all are the integers here. So stop the iterations. Thank you.